So right now we have covered chapters 1, 2, and 3. All right, you had a test on 1 and 2 yesterday. So chapter 3, how to code and test a Windows Forms app, I will tell you that the test you'll take Friday, all 3 of them, I believe, are Windows Forms apps. All right? Okay. So we're going to start chapter 4 right now. Now let's look at what's left in this section. In fact, if we go through 16, let's look at what we do for the rest of the semester. All right? And you know, you don't have to write this down. You don't have to remember it. I just want to show it to you. So we're going to go over chapter 4 after we take the written test. How to work with number data and string data. Then we'll do chapter 5, control structures. Guess what those are? If statements and loops. We have touched on those already. We will again. There's also something called a switch statement. We'll talk about that. Then in chapter 6, rather than putting everything in main, all right, we'll start moving stuff around and we'll write our own routines. Chapter 7, that's when, right now, remember how I told you, if you asking for a number and you put a non-number in, it'll break? We'll fix that in chapter 7. From then on, it won't be an issue for you. Chapter 8, in this section, probably the hardest chapter because it's on arrays. All right? And people go, I don't understand them. We'll do a lot of work with them. Chapter 9, dates and strings. There's a lot of built-in string functionality. By that point, you'll understand it when we go over it. Same thing with dates. Chapter 10, additional stuff for working with forms and controls. Chapter 11 is debugging. I already, for lack of better words, kind of warned you about this, that what we'll have in chapter 11 is I'll give you a program that doesn't work. And I will ask you to identify all the errors and make it work. That's part of what you'll do there. And then in section 3, it's all on object-oriented programming. Now, I'm taping this, so if Evan hears it, I'm hoping he won't be mad. But I'm hoping to be done 2 to 3 weeks before the end of the semester. Why? First of all, it's my rule, the last week of the semester, I want you working on your portfolios. You know, and again, because I don't know what those are, we're going to go over them. All right? But I want to give you plenty of time to work on those. I believe your last day is a Wednesday, May 6th. To my knowledge, that's the last day. So that last week, that's what you'll do those 3 days. All right? And then before that, I'm not going to have enough time to go through 4 chapters, but I want to introduce you to databases. You'll have to understand databases for the course that Maya and Keegan will take in fall. But we also, not that you guys will need them so much for next semester, but you at least should get an introduction to them. All right? So that's what I plan on, hope to be able to do. So I'm going to pause this because before we go over chapter 4, I want us to get ready to take the chapter 3 written test. So I'm going to take this. It's only 3 minutes. All right, she's not back yet, but I said 9 o'clock and it's 9:01. So, all right. Chapter 4 begins in your book on page 99, and it's entitled, as you can see here, How to Work with Numeric and String Data. This is the kind of thing to realize. Don't memorize this stuff. Just know where to look for it. And I may have said this to you before, but I'm going to say it again anyway. And that is, when you're in doubt about something, about the language, and you're like, I'm not really sure about this, go out to here. Go out to msdn.microsoft.com. MSDN is an acronym that's short for Microsoft Developer Network. All right, you can find virtually anything there. Now, look on the screen if you would. That's where I went when I hit enter. It pushes me off to docs.microsoft. You know, you might find something goofy like this. This is new. It wasn't taking you to docs before. So what I'm telling you is that's where you want to go. In fact, let's just say that I came into Google and I typed in this. How to convert a string to an int C# what you're almost always going to find is one of the first ones that's in there, maybe not the first, will be this. Now it's docs.microsoft, but that's it. All right. And always make sure if you're checking for something at the beginning or at the end, put C# in there. So otherwise, if I just put in how to convert a string to an int, it's going to give me how to do it in JavaScript, how to do it in Java, etc. Okay? All right. Get rid of this. So we'll talk about the different data types. We'll talk a little bit about strings. And there's stuff in here. Like I said, you probably won't remember every bit of it. It's not to be expected that you'll remember every bit of it. All right? Such as, Jeff. Well, look. Here's the built-in different types that you have available to you in the language. All right? I think the other day it might have been Christian, it might have been Keegan. Somebody asked about, well, what's an int 32? Well, if you look right there, they don't even show it. They just have int. But the thing is, what an int 32 is this one. It is an int. So notice, I guess I was wrong. I thought it went from negative 4 billion to positive 4 billion. It's negative 2 billion to positive 2 billion. It's probably big enough to handle anything we'll do. But, in all seriousness, if you're doing something on the national debt, not big enough, right? So then you'd want to use what's called a long. I cannot tell you what this number is. I don't know. I know that it goes, millions to billions to trillions, and I think next is quadrillions. I don't know what the next one is. I don't care because it probably won't ever affect my life. All right? I will tell you, if I ever win money like in that amount, don't expect to see me here the next day. All right? I mean, I would finish out the semester, but I'd take a day off. I haven't had a drink in about 40 years, but I would have one if I won $1 trillion. All right. So how to declare and initialize variables? First of all, look at these examples. There should not, what happened here? Come on. What happened right there? There we go. There shouldn't be anything in here that's a surprise to you. Again, this is declaring, this is initializing, right? You can do it as one line or you can do it as 2 lines. Think about when you'd want to do it as 1 line. Okay, let's assume that I'm writing a program about my birthday. And I know that my current age is 63. Then there's nothing wrong with saying int age equals 63. Make sense? Now let's suppose I'm writing a program about Dominic's birthday. I don't know his age. So I just say int age, or maybe I even set it equal to 0. Then I ask him with a write statement, hey, Dominic, what's your age? And he comes back and he says 21. Well, that's going to be put in a read line, right? And I'm going to have to say age equal convert.toInt32, then in parentheses, read line. Do you all get that? Because you should. You just did it yesterday. All right? And if you're not doing it that way, you're going to be doing something like this. Where let's say that you do this. You've got a thing in here that says, I don't know, let's say that you're doing something with miles and kilometers. All right? So I put in here miles. And I put in here kilometers. I think you'd all agree with this. I could run this program hundreds of times and put a different number in there every time. Click a calculate button and get a different number in there every time. All right? So probably for these 2 variables, if I would declare them, I would probably say something either int or double, depending on what I wanted to do. But maybe double miles equals 0, double kilometers equals 0, something like that. Remember with constants, it's const. Now notice our author only puts the first letter of each There are many languages. It's pretty much considered an unwritten standard that constants are all capital. All right? So they define a variable here. We've already talked about that. They define a constant here. Just so you know, if you look on the screen here, if I do this, if I say, let's just grab this one. Double price equal 14.95. Everybody see that in blue? 14.95 is called a literal value. A literal value can only appear on the right-hand side of an equal sign. I couldn't put 14.95 on the left-hand side of an equal sign. That wouldn't make any sense. All right, arithmetic expressions, you've looked at these. I'm asking, is everybody comfortable with at least the four main ones? Addition, subtraction, multiplication, and division? All right. Modulo that's right there, that is that remainder operator. All right. You can put a plus sign if you want. So if you look at the line right here, instead of saying x equal 14, you could say int x equals plus 14. It's redundant, but you can say it if you want to. Doesn't hurt anything. The negative makes it negative. Now, I do want to mention this increment thing. Let's put something up on the board here. All right. In fact, let me, just for a second, I don't want to make it blue. Here, let's do this. I want a white background for just a second. All right. I want you to understand this, so once I put it up there, if you don't get it, ask. Okay? I'm going to create two variables. Int x equal 10. Int y equals 0. Typically, with most programmers, if you make the number 0, you put a line through it like that. The reason you do that is otherwise people think it's an O. All right? Now, if I say this, y equals plus x, and then I want to say this, y equals x plus plus. I want you to understand the difference between these. This is called pre-increment, because the plus plus comes first. This is called post-increment. All right? What does that mean? That means right here, what happens first is you add 1 to x. So x is now 11. That makes sense? So x equals 11. Then you take that 11 and you assign it to y. So y equals 11. And if you go, that's too confusing, then don't use it.
You only use the pre-increment on x, or can you put it on?
You can put it on anything, but it can only be used to add 1 to something. You can't add more than 1 using plus plus. Now, in this case, it's post. So it takes x, which is 10, and it assigns that to y. Then it adds 1 to x. See the difference? With a pre-increment, they both change. With a post-increment, only the one that you assign to changes. And again, if that confuses you, do not use it now. All right? I've had people say, okay, I get this. Could I just do it like this? Can't I just do it in two? Then do it in 2 lines. Do it whatever way it's easier for you to understand it. Does that make sense? All right. Now, I've got x here, and I've got y here. You know what? I don't care any. Well, yeah, we'll leave y. That's fine. Now, we don't even need it. We'll remove y. So, if I want to add 1 to x, you now know at least 2 ways of doing it. So if I want to add 1 to x, I can say plus plus x. I can say x plus plus. I can say x equals x plus 1. Or I can say x plus equal 1. All four of those ways will add 1 to x. Does that make sense? Now let's say I want to add 5 to x. All right? Then this is gone and that's gone. I can't do that. But I can come in here and say x equals x plus 5, or I can say x plus equal 5. And there is a plus equals, there is a minus equals, there is a times equals, there is a divide equals, and there is a modulo equals. They're all shortcuts. If they confuse you, don't use them. The idea is 1, 2, 3, 4, 5 characters, 1, 2, 3, 4 characters. And again, you might say, it's just a character, who the heck cares? This actually will execute faster than this will. It breaks into the zeros and ones faster than the other one does. You just said, why? I don't know why. I just know that internally, that's the way it works. Okay? And again, you say, well, I'll never remember all that. Well, then what you might want to remember is the page of the book we're on. Sometimes people dog-ear that page, fold it in at the top, or write it at the beginning of the book, or whatever. Whatever works for you. $105. All right. How to code assignment statements. Well, there's what I just showed you. Equal, plus equal, etc. So I'm not going to go over that anymore. All right. Order of precedence. Look at this. Look on the screen here, please. You do increment and decrement. Then you do positive and negative. Then you do multiplication, division, and modulus. Then you do addition and subtraction. Now, that's it. For right now, pretend 1 and 2 aren't even there. In actual mathematical operations, you do multiplication, division, and modulus, because modulus is a type of division, before you do addition and subtraction. To change that, you use parentheses. So if I write this, A equals B plus C times D minus E divided by F, something like that. What's going to happen is this will be done first. Because it goes from left to right, and it says, I got to do that before I can, no, then I got to do this next. So that's first, then that's second. Then third, it does that addition. Then fourth, it grabs everything, and it does the subtraction. If I don't want it to work like that, oops, A equals B plus C times D minus E divided by F. I can change it. Now look, if I do this, now it does this first, it does that second, then it comes through and it does the multiplication third, then it grabs everything and it does the division fourth. All right? And I don't know about you, but I believe it was maybe in junior high they taught us that, because they knew in high school some of us at least would be taking algebra. All right? It hasn't changed. It works the same way here. Casting, we have not looked at that yet, but let's look at it right now. All right? So let's assume this. Don't even worry about what they wrote up here. I want to just give you an example. All right? I'm going to come in here and say this. Int x equal 5. Int y equals 9. Double z equals x divided by y. Can anybody tell me? Look on the screen. Can anybody tell me what z is equal to? What's that?
Z is equal to 5 divided by 9.
X divided by y.
You're all wrong. Z is 0. Because what happens when you divide one whole number by another whole number, since it's int divided by int, it throws away any remainder. So even though the answer is 0.555555, it throws away everything after the decimal. How do you fix that? 3 different ways you can fix it, at least. One, I can do this. Instead of doing it like this, I can say z equals double x divided by y, or I can say z equals x divided by double y, or I can cast them both and say z equals double x divided by double y. Would you agree that in all 3 of those cases, the word double is on the right-hand side of an equal sign? Would you all agree with that? That means you're not changing it. You're working with a copy. That's why that you're allowed to do that. All 3 of these will make z equal to 0.555555 or whatever that is. All right?
Why don't you, I'm just a little bit confused because wouldn't you have to put double on both of them?
On these? No. What it does is it changes this literally. It says, oh, that was 5, make it 5.0. This one, it changes it. Oh, it was 9, make it 9.0. This one makes that one 5.0 and that one 9.0. All right? But it needs some help, so to speak. Okay? You can do casting in a lot of different ways. But sometimes if you try to cast something, the system might not have any idea what you're trying to do. All right? And I mean, you can cast a number into a string. Isn't it? That's what toString does. It says, this is no longer the number 99. It's the string 99. It has no arithmetic value to it. So it just depends on what you're trying to do. All right? And as always, all kidding aside, how do you learn this? You learn it by practicing. You try something. You know, I have had students over the years many times told me, you know, I didn't understand at all what you were talking about, and I didn't really want to ask, so I went and wrote my own program and just kept banging on it, and now it makes total sense. Good. You learn it the way you learn it. You know what I'm saying? Some people can sit and read a book, and they come to class here, and they look at me, and they're going like this, and they're like, oh, God, when the hell do we get out of here? Because they're not listening. And I get it. I mean, because everybody's different. Some people can read and retain. Some people can listen in class and never read, and they retain that way. All right? Whatever works for you. So here are some ways that you can cast. And again, you can read the explanation if you want more, you know, than what I just gave you. All right, math is a built-in, it's a built-in class. Most programming languages have a built-in class called math. I've got a question for you. What is this known as? If I say y equals x times x, would you agree that's the same thing as x squared? Would you agree with that? And if I say x times x, I should have put something other than x, but that's like x cubed, right? Would you agree with that? Another way you can write this is y equals math dot pow x2, or y equals math dot pow x3. They do the same thing. So why would you want to use this instead of this? Well, first of all, it is less typing. Second of all, what if it's 27? Seriously. Do you want to write x times x times x times x times 27 times? If I can do it like that, I'll do it like that every time. This will also, again, execute faster than this will. All right, you'll notice there's a rounding function in there. This rounding makes sense to everybody. If it's 0.5 or more, it rounds it up. If it's less than 0.5, it rounds it down. Okay, square root, I think we all understand what square root is. You can notice there's a min-max. See that last one? You can provide a number here and a number here and a number there, and if you call math.min, it'll return the smaller one. If you call math.max, it'll return the smaller one. If they're the same number, if they're both 7, it just returns the first one that it finds, because they're the same. And there's other stuff. If you want to know, there's other stuff that you can do in here, but most of the other stuff, I still remember asking the teacher once, when stuff has changed over the years. When I went back and got my 2-year degree, okay, first of all, it's called data processing back then, because that's how antiquated I am. All right, but it was called that, and we had to take a class called technical math. And for instance, I could figure out the cotangent of a negative 432 degree angle. Okay, and I remember asking the teacher once, and he knew I wasn't being a smart aleck, but it was Mr. Andrews. I said, Mr. Andrews, why am I ever going to need this? I mean, first of all, I said, I can't see in the field I want to go into. I can't see this ever helping me. He said, it's the thought process. That's what you're getting, is the thought process. And then I watched him, as he was grading them as I was doing this, and I said, wow, must be nice to be able to just type in negative 432, press the cotangent button, and get the number. And he's like, well, you got 100 on your test. You can do it now. But all I'm going to ask is that you sit in the back of the room and you don't, with other people, know what you're doing. And he said, don't tell them. He said, if they ask me, I'll tell them they can use a calculator. But if they don't, so while we had like 3 tests after that, I just used a calculator. That was a lot nicer. But that's what we're kind of doing is with the math class is we're saying, hey, you've got this built-in stuff. We want to use it. And they have stuff for tangents, cotangents, logarithmic. They have a lot of that stuff that's in there. How do you find out more? You go out to docs.microsoft.com or msdn.microsoft.com and you look up the math class. All right? All right. Strings. What's a string? Something you put in double quotes, right? Do you all get that right now? See this? What is the official name for that? No. You're making it hard, too hard. It's the empty string. That means there's nothing in it.
So then it's free for...
That means there's nothing in it. This, right here, do you know what that word means? Yeah. Literally, in when you're talking about it in terms of programming, it means unknown.
What's the point of double quote?
It is initializing it so there's nothing in it. That's all it's doing in that case. But you put why do you make it the empty string? Mm-hmm. Because in some programming languages, if you don't initialize it, it's got garbage in it for a value. It's whatever garbage happened to be in that memory location the last time it was used. The one it gets assigned to. So most people, just for safety reasons, do that. All right. Would you guys, the 3 of you, agree that when you walked in here the first day, if this was the first class you'd ever been to, I don't know if you have other ones, let's just say this was the first one you'd ever been to here, and I said, what's your GPA? You would have been right to say, I'm just starting, I don't have one. I don't know. Would that be a fair assessment? That's kind of what null means. It means unknown. But it's a lot different than saying, oh, I don't have a GPA right now, it's 0.0. I don't think you'd want that, because for one thing, you'd be on probation. All right, literally, you'd be on academic probation. Mr. Corrigan was telling me that we have this thing. It's called the ADRB, the Academic Disciplinary Review Board, where if somebody gets in trouble, they have too many absences or whatever. He had to go at the beginning of the semester. He had a guy, all sorts of problems. I'm not at the person's own business. He said, Jeff, that guy had a GPA of 0.73. That was one of the lower ones I'd ever heard of. That means he completed classes, you know that. And he got at least one class he didn't fail, right? Because it would have been a 0-0 otherwise. All right. Now, notice, you can do this. You're like, Jeff, you always have us use the 2-string. See that? You can do it without 2-string. It's never recommended you do that because you are then mixing apples and oranges. Almost always it'll work even if you don't use the 2-string. But you really shouldn't do it like that anyway. It's almost like, I remember when I was starting to drive, my dad would always tell me, My dad was a part-time cop at the time. And he'd say, you can go 5 miles an hour over the speed limit. Don't worry, nobody's going to pick you up. You know, it's just not going to happen. Then a few years later, it was, you can go 7 miles an hour over. Then right before he stopped driving, so you can probably go 9 miles an hour over. I wouldn't go 80 in the 70 zone, but usually 79, they won't pick you up. Well, it's sort of the same kind of thing. It's, you don't have to do this, but you could get bit in the butt. Something weird could conceivably happen if you did that. All right? You can use, there's a plus equals. Remember we looked at that for addition. You can use that to also plus equals to combine strings together if you want to do that. Do you have to? No, but you can. If I say this, string first name equal Bob. Bob is known as a string literal. It's a literal value. Remember, literals can only appear on the right-hand side of an equal sign. String variables can appear both on the left side and on the right side. All right? And it may sound like a minor thing. Make sure when you put string in there like that, lowercase s, because uppercase S means something else in this language. In Java, you have to use an uppercase s because a lowercase s means something else. So different languages handle this stuff differently. All right, how to put special characters in strings. These are called escape sequences. These two are probably the ones you're going to use 99.9% of the time. That's a new line. That's like hitting the enter key. We've already looked at that. The other one's a tab. All right? And you might say, well, what's the difference between a new line and a return? Return literally is like you hit the return key, but it doesn't necessarily move you to the beginning of the line. You don't typically want that. All right? And they give you some examples. I'm not going to go through any more of them than this. How to convert data types. Guess what? You've looked at some of this already. We did the convert dot to int 32. We did the convert dot to double. You can do a convert dot to any of these. If I've got a number, if I ask somebody, how much money do you make per year? And let's say you make $50,000, okay? Don't use byte, because byte's only designed to hold negative 127 to positive 128. When in doubt, just use the int 32, because that's got negative 2 billion to positive 2 billion. Almost always going to be big enough. All right. The string and the object we're going to get to in much more depth later on in the semester. So these conversion methods, we've already looked at toString. Would you agree with that? All right. In a later chapter, we're going to do parse and try parse. Those two. When we do that, if you are writing a program, and this will work both for a console and for a form. If I ask you an age and you put hello in there or you leave it blank, the system will then handle it by using those parses and try parses. I'm going to hold off on that until we get to that chapter. All right. We've done these already, though. Convert dot to decimal, convert dot to double, convert dot to int, etc. All right. Using methods to convert numbers to strings. Some of this we've looked at. Look on the screen here. That means currency. See that? It means currency. You can use a little c or a big C. It doesn't matter. There really is no difference. This means percentage with 1 decimal place. This means numeric with no decimal places. This means floating point with 3 decimal places. And I'm not saying, does that totally make sense? The only way it'll make sense is for you to start using it. All right? Once you use it on a regular basis, it makes sense. Again, what page are we on? 129. No, 123. That's kind of your window to the world as to what each one of these means. 3 other skills for working with data. First one is scope. Now, I'm going to go over this with you, and it may not make a lot of sense. But when we get to a later chapter, it'll make more sense. Remember how I told you to define your constants right up near the top of the program? If you define something, whether it's a constant or a variable, if you define it outside of any method, main is a method, etc. If you define it outside of any method, it becomes global, which means it can be used anywhere in the program, and you don't have to do what's called pass it around. If I declare a variable in here, we don't have one, but let's say I declare a variable named age in here. You with me? And I need that variable in here. Then I have to do what's called pass it. And what does that mean? I put it in parentheses when I call the method. If you go, I don't get that. That's what we're going to be doing in later chapters. All right? So, if you define a variable that's outside of any method like this, it lives as long as the program lives. If you define a variable inside of a method, while the method is alive, the variable is alive. Once the method dies, the variable dies. Does that make sense? And enumeration. An enumeration is a user-defined variable type. You're like, oh yeah, makes sense. Clear as mud. All right. You typically create an enumeration like this. Why? You typically create it because it makes your program easier to read. All right. Now, if I was going to create an enumeration, I would do one like this. Not like they have there. There's nothing wrong with that, but I would do this. Enum grades. All right, and I would have A, B, C, and F, because those are the grades that are available here at Rankin. I can put it all on one line if I want to. This can all be on one line, as long as there's commas between. Doesn't matter. All right? Or I can come in here and say, oh, those are all strings, or chars, or whatever. Now I've got a new variable type that's called grades. And the only four values that it can hold are A, B, C, and F. Does that make sense? All right. And again, we'll deal a little bit with those as we go on in here. Some people like to use them a lot because they make your code much more self-documenting. All right. Imagine that I was doing a program for somebody who was an arborist, a tree person, and they worked with three kinds of trees. And I made an enumeration where I had oak, maple, and whatever. You know what I'm saying? Then I would be able to use the word oak and the word maple, etc. It would probably make it much easier for them to understand what I was doing. That's typically why you use enumeration. Popular enumerations, days of the week. Monday, Tuesday, etc. People like that. You can give them values. See that? If you don't give them values, they automatically default to 0, 1, and 2. Did you hear me? All right, if you don't give these values, they default. The first one's 0, the second one's 1, the third one is 2. If we had done this, if we had said net 30 days equal 30, and just for now, pretend those aren't there, then this next one would be 31, and the one after that would be 32. All right? Why am I telling you that? Because that sometimes people just take the first one and increment it. A lot of people don't like the fact that the first one's 0, so they set the first one equal to 1, and then they just go on. It's all a matter of, personal preference or lack of something better. All right. Nullable types in the null coalescing operator. Let's look at that. Again, if you set something equal to null, it means unknown. All right. Now look on the screen because this is important. See this? See how these have question marks? You see that? If you leave the question mark off of a numeric variable and you try to set it equal to null, you may get an error. This basically means it's possible for that to be equal to null. So it's considered a safeguard to put that in. Does that make sense? Again, you're getting so much stuff thrown at you. You might say, yeah, it makes sense. I'm sure as hell never going to remember that. We're not going to be dealing a lot with that. It becomes more important like on the object-oriented side when we get to chapter 12. All right. So they come back and they write an invoice application, and they write it like this. So you put in a subtotal. Notice these are all grayed, meaning that they're all text boxes with read-only set. So what do we have? We've got 1, 2, 3, 4 labels, 1, 2, 3, 4 text boxes. 1 text box is not read-only, 3 are read-only, and 2 buttons. So they give you their names there. They set up the event handler, and they set up the code. All right, I'm not going to run through that. It's totally fine. Then they go and they give an enhanced version. Why is it enhanced? Look on the screen. This is what they had originally. Now they want to be able to do more than one of them. So every time you click clear, all right, now instead of you start a new invoice, the number will bump up. And these things, if the first time our total was 169.12, then our other two would have been equal to about 1,000. Does that make sense? These things are called accumulators because they are accumulating the total number of invoices, the total number or the total invoice amount, and the total average invoice. All right, so it's going to involve, as you probably guessed, more code. And that's it. So